So we'll start again trying to find out the Rankine's load and the Euler's load. It says that it's a 2 meter long column. So here LE, guys, here in this 1 plus A, LE effective length, it is 2 meters, and it says with both ends inched. For both ends inched, LE is equal to L for both ends inched. Okay, so I substitute this as how much? 2 meters. So LE is equal to 2 meters. Everything is in terms of mm. So I am now substituting it. This is this, and I don't know K. So K has to be found out. And then A is given as 1 by 1600. And then what is missing is A. Area is, here it says that the cross sectional area is 10 into 20. So we are now worried about this area, which is actually 200 mm square. Okay. Now what I don't know is A. Let us find out A. Now I don't know K. So I know that moment of inertia is also given by the formula AK square. So here this is I minimum. So I refers to I minimum here. So I minimum. So for this section here, for this section of the column, you can have the section like this, 20 mm into 10 mm. You should take the least moment of inertia. So if I actually take like this, this becomes the depth, this becomes the breadth. So you should take that. So I minimum is B is actually, B should be taken as 20. This should be taken as depth divided by 12. What's the answer? 166.66 millimeter to the power of 4 I minimum. And then 1,666.66. So let us find out. So 1,666.66 millimeter to the power of 4 multiplied by area. Area, you know that this area is 200 mm square. So you can find K. So K square is equal to root of I by A. Sorry, K is equal to, so K is equal to I by A. Sorry, K square is equal to I by A. K is equal to root of I by A. So much is the answer? 2.88. So this is mm. So that has to be substituted here. So this is 2.88 mm. Okay, here you can see that this mm gets cancelled out, and this millimeter square gets cancelled out. What is only left is newtons. So here the answer that you get is in newtons. So what is the answer that you get here? Now what is the answer that you got? But substituting this, I think you got the answer, no?
Yes, sir.
What is the answer?
Sir, 264.54.
264.
54 divided by 3, 88.18.
I think you already divided, no?
Yes, sir. 88.18.
No, you already divided and you got this 264.
Yes, sir.
Don't divide by twice.
We didn't divide, sir. We substituted direct 400 itself. After that, we divided.
Okay, now,
For that, 88.1.
so right now you got this as 88. Huh?
Yes, sir.
Guys, are you sure?
Yes, sir. Square will be 200 mm square.
So this is square, huh?
Yes, sir. There one.
Okay, sorry. This is missing. Now the square was missing.
Then the unit will say
88.17 newtons. I think this is a very, very small load. 88 newtons is like how many kgs? 88 newtons is how many kgs? Like 8.8 kgs almost. Okay, 8.8 kgs. So how much is this rod long? This is like 2 meters long. So 2 meters is literally taller than me. And what is the section? 10 mm is 1 centimeter, 1 centimeter by 2 centimeter. Suppose if there is a rod of this and it is 120 GPa, it is not even steel, maybe like copper. It's a copper rod of 1 centimeter by 2 centimeter. It literally starts failing by, it starts failing at that load. And this formula, Rankine's formula, is not good for long columns. Long columns usually this Euler's formula. Okay, Rankine's formula is good for medium length columns. And it's good for both, but the answer will be slightly wrong. Here we are using two formulas for the same condition. We'll see with this Rankine's formula what we are getting the answer. With this Euler's formula what we are getting the answer. We'll see now. Okay, you got this as 88.17, huh? Okay, now Kevin got this 88.17 newtons. Now let us find out what is the value that we will get for Euler's load. Euler's load. So Euler's formula will be what? Pi square EI minimum LE square. I think this is direct formula, no issues. And here, this is, you are not dividing it by 3. We will try to divide by 3 after finding the load. Okay. So pi square 3.1 square multiplied by E. E is how much? 120 GPa. 120 GPa has to be written as 120 into 10 to the power of 3 Newton per mm square. And I. So I is how much, guys? I minimum 0.66 millimeter to the power of 4. Divide by LE square. LE is how much, guys? 2000 millimeter square. So this is direct substitution. It is the reason why only you will get 4 marks. I think it's these problems are straightforward and 493.47 newtons. So taking without FOS. So this is without factor of safety. And with factor of safety of 164.4. With factor of safety of 3, so 493.47 divided by 3. So much is the answer? 164.49. So which you can call it as 165 newtons. So 165 newtons is the load that can be taken by Euler's load. So Euler, by using Euler's formula, you feel that you are able to take like 16.5 kgs. If it is a load of around 16.5 kgs, here only you are able to take 8.58 kgs. Okay, so you can know that these formulas are not giving, they are giving different answers, which means that they are not suited for the same applications. Okay, it is how most of the numericals come. Most of the numericals are related to finding Euler's load and the Rankine's load. The same formula, no change. So you should be able to substitute the values and get the answer.